Okay, so let's go through every second question of the homework. We're starting off with this one. We actually do need part A in order to get the rest of the questions, so I'm going to do that one. How many letters are there in the word teacher? That's 1, 2, 3, 4, 5, 6, 7. And we need to know this number because this is the total. Okay, so when we're finding probability, I need to find the amount out of the total. So it's going to be out of 7. So the probability that the letter is an R. Well, how many R's are there? There is 1. So this probability is just 1 over 7. Okay, how about not E? How many letters are not E? Well, there's T, there's A, there's C, there's H, and there's another R. There's 5 of them. So 5 out of the total, 5 out of 7. Remember, probability is given by, probability is favorable divided by the total outcome. Yeah, and so that's why we needed this number, this total, before to get our answer. Let's have a look at question 5 then. The letter is chosen from the word experiment. Find the probability that the letter is, and I'm going to skip A and go to B, a vowel. So what is a vowel? A vowel is A, E, I, O, and U. And so there's 1, 2, 3, 4 of them. So it's going to be 4 of them are favorable. So it's 4 divided by, and it's going to be the total out of the total. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 out of 10. And what I can actually do with this is I can simplify it. Right, because as a fraction I can simplify 4 over 10. I realize the top and the bottom can both be divided by some number, namely 2. So I'm going to halve the top, it becomes half of 4 is 2. I'm going to halve the bottom, half of 10 is 5. And that's fully simplified because I cannot go any further than that. Let's have a think about the next one. It's an X or a vowel. So when we're OR, this word OR, it doesn't matter if it's an X or a vowel, as long as it's either one of them. So how many of them are X or vowels? So 1, 2, P is not an X or a vowel, so that doesn't count. 3, 4, 5. There's one more than before. It's 5 out of 10. And I can do the same thing as before. I can simplify this because I realize top and bottom can be both divided by what number? Hopefully you realize it was 5. So 5 divided by 5 gives us 1, and 10 divided by 5 is 2. 1 over 2 is 50%. There's an odd probability. There's an even chance for you to get X or a vowel. Okay, so question 6, well, this is an example for us, is an experiment that involves tossing 3 coins and counting the number of heads. So it's an experiment. I'm tossing not 1, not 2, but 3 coins. So there are 4 outcomes for this actually. They can all be tails, or one of them could be heads, and the rest of them tails. Doesn't matter which order, as long as you've just got one of them. Or 2 of them could be heads, and then the other one a tail. Or all of them could be heads. So those are kind of our 4 options for us to happen, and we're going to do every even one. So B, let's have a look at B. How many times did fewer than 2 heads occur? And so 3 is not fewer than 2, so I'm not going to use this number 13. 2 is not fewer than 2, it has to be less than 2, so the only numbers I'm counting are 1 and 0. So 11 plus 41 gives me 51 favorable outcomes. How many are the total outcomes? Well, actually it doesn't even ask that, it says how many times did they occur, so I don't need a probability. It's going to be 51. This is how many times it occurred. Less than 2 heads. Okay, find the probability of obtaining, we're skipping the first one and going 2 heads. What's the probability of obtaining 2 heads? It's 2. I want exactly 2, so 36. 36 is out of What number? Well, we did the experiment 100 times, or you can just add all these numbers together and you should hopefully get 100. Can I simplify? Hopefully you realize it's going to be 18 over 50, and finally it's going to be 9 over 25, and that should be our last one. Question IV then asks us at least one head. Well, at least tells you need one or more. So it's going to be 1 plus 2 plus 3. So those ones added together. So 40 plus 36 plus 13. And that number is 89. What is the probability though? It's 89 out of, and the total amount that I need is 100. And so hopefully you understand what's going on over there. Okay, let's keep going. Question 6, from a group of 50 adults. So that's important. That tells me the total amount of adults. 35 enjoy reading fiction, 20 enjoy reading non-fiction, and 10 enjoy reading both fiction and non-fiction. And question A asks us to illustrate the information in a Venn diagram. I'm actually going to do that question so that you understand what's going on there. I need to start by drawing my circles. Label one A, one B, and I want to finish off with this square around the outside. 50 adults, that's my total. I'm looking for 50 adults in my total. 35 enjoy reading fiction. So maybe A is equal to F for fiction. And non-fiction 20, B is equal to N, non-fiction. Can I put 35 enjoy reading fiction? Well, fiction is made by the circle that is A. Let me represent A in a different color. There we go. And hopefully you realize that A is going to be made from one number over here and another number in the middle, because that's still part of this A circle. So I actually cannot put 35 down, because 35 is the sum of these two numbers. And for the same reason, I can't put 20 down either, because 20 is going to fit in the other two circles. And I don't know how many go in the middle and how many go in this one. However, this last piece of information will solidify everything. It tells me that 10 enjoy reading both fiction and non-fiction. So the number in the middle is going to end up being, get it? Working, no. Number in the middle is going to be 10. Okay? 10 of them enjoy reading both. And so now that I've figured out this 10, I now know that 10 plus some number is going to give me how many people enjoy reading B, B's, and non-fiction. How many people enjoy reading non-fiction? 20. So 10 plus what number gives me 20? 10. So 10 plus 10. And finally, similarly, going the other way, 10 plus some number gives me 35, and that number is 25. Let's count them up. 10, 20, and 45 altogether in my numbers. What is my total meant to be? It's meant to be 50. So 5 is going to go down there. Okay, so that's my Venn diagram. And now I need to state the amount of people who enjoy fiction only. Now, fiction only is the section of fiction, which is part of A, that is not shared by B. And the number that is not shared by B is 25. So I know that the people who enjoy fiction only is 25. Moving on. Who enjoy neither fiction nor non-fiction? That tells me people who don't enjoy either one of them. So the number that's outside the circles of A and B is this number, 5. So this is 25, this is 5. Okay, having a look at question C, find the probability that someone chosen at random will enjoy reading non-fiction. I'll leave you to do that by yourself. Non-fiction only. Where's non-fiction? Non-fiction is B. So the people who enjoy non-fiction only is the part that's not shared by anything else. That's 10. So the probability is 10 out of, and the number of total people is going to be given by 50 adults. Hopefully you can simplify this easily by crossing out the zeros and you get 1 over 5. So 1 over 5 is my final answer here. And for both fiction and non-fiction, well, that's going to be the crossover. And is where they have in common. It's this number 10 over 50 again, same answer, 1 over 50. And okay, so that hopefully should be helpful for us. We're going to speed through the rest of them. At a show, 45 people have a choice of riding a Ferris wheel or the Big Dipper B. 30 of them wish to ride a Ferris wheel, 15 want to ride the Big Dipper, and 10 want to ride both. Let's illustrate the information on the Venn diagram. I'm going to do this really quickly. So, circle, circle. Okay, what numbers can I put in there? I need to know that 45 is my total. 35 of them wish to ride the Ferris wheel. That's this circle, it's covered by 2, so I can't add anything. 15 want to ride the Big Dipper, so again, that's this overlapping circle, I can't put anything. 10 want to ride both. So 10 goes in the middle. Now, I'm going to put F here for Ferris wheel, B here for Big Dipper, and what I've got then is I need to find out the totals. 35 want to ride the Ferris wheel, so this big circle have to add up to 35. So what number plus 10 is 35? It should be 25. 25 plus 10, 35. So I'm good with 35 children. And 15 want to ride the Big Dipper. So 10 plus, hopefully you got 5. This gives me 25 plus 5 is 30 plus 10 is 40, but there are 45 children. So 5 people who are missing belong outside the box. Great. So question B asks us to state the number of children who want to ride on the Ferris wheel only. Only is the Ferris wheel people who are not shared by anything else. That's 25. Who want to ride on neither the Ferris wheel nor the Big Dipper, so none of them don't want to ride at all. That's this number on the outside of the 2 circles. So that's 5. Okay. For a child chosen at random from the group, find the probability that they want to ride on the Ferris wheel. I'm going to let you do that question. Both the Ferris wheel and the Big Dipper. So and is the intersection. It's the common overlap, and it's this number, 10. I want the probability, so it's 10 out of 45. And this simplifies, if you divide it by 5, is 2 over 9. Yeah? Okay, who want to ride not the Ferris wheel? So now I need to realize that the Ferris wheel is made by the number 25 and 10, and so not these 2 numbers is these 2 numbers. And 5 plus 5 is, again, 10 over the total amount is 45, and that leaves me with 2 over 9 again. Alright, our last couple of questions are about two-way tables. State the number of elements in these events. A and B, and you're meant to realize that A and B is the cross section of A and B, and that's this number. This is 4. I is A only. A only is the section of A that is shared by not B. So it's going to be this number, 6. B only, similarly, is the part of B that is crossed over with not A, because it's not shared by A. And that's that number 3. Neither A nor B is not B and not A. And so that is that number 1. And A is made by this number 10, because this is the whole section of A crossed without anything else. B similarly is this number 7 crossed with nothing else. Not A, 4 crossed with nothing else, and not B, 7 crossed with nothing else. And you want to know A or B includes A and B, A only and B only. So you want to find the number of elements in A or B, and it doesn't matter whether it's A or B. So it's 4 plus 3 plus 6, and you don't add this number because this is neither of them. So 4 plus 6, 10, plus 3 is 13. There are 13 people here.